Welcome to Study Loop.
A little bit of a lengthy problem, but that's all right. So we take this and then we react it with this ester. Of course, you can have some sodium ethoxide and ethanol to get this reaction going. We'll access this product because, of course, this alpha carbon acts as a nucleophile to attack this carbonyl electrophile. Haven't lost this alkyl chain. Next, if we use the same reaction conditions, but a different electrophile, specifically this Michael acceptor, then this nucleophilic carbon will go ahead and attack this position. And you'll generate this Michael addition product. Next, if you use sodium ethoxide, this ethoxide can actually attack this aldehyde to generate this tetrahedral intermediate. At this point, this anion can come down. Instead of kicking off this ethoxide group, can actually break this carbon-carbon bond. To kick off this ester. Oops. At this point, we'll have the enolate form. And this enolate form can, of course, tautomerize. Did I miss one carbon there? Yeah, I have. My mistake, guys. So all of these, of course, we have 1, 2, then the carbonyl, so that should be 1, 2, and then this carbonyl, 1, 2 to the carbonyl, and here 1, 2 to the carbonyl. Okay, and then next we have some annihilation reaction which occurs. So under acidic conditions, this aldehyde can, or this ketone can get protonated, and at the same time we can go through the enol form here. This enol form can come around to attack this carbonyl. So now this carbon here forms a bond with this carbonyl, which opens up to the hydroxide. Of course, we still have this methyl group. And at this point, we have loss of water, dehydration. So this is the unusual part of this reaction, because we're under acidic conditions. Normally, we would deprotonate this alpha carbon here, because it's very acidic, being adjacent to the carbonyl. However, in this case, you can see we don't have any alpha protons available. So we're going to have to lose this proton, which is adjacent to the hydroxyl group. To generate our end product. Lastly, for question E, it asks, why do we add the formal group in the first step if we're just going to remove it in a later step? Well, the nice thing about adding this formal group is that we make this alpha carbon extremely acidic. So this is going to be the selective nucleophile for the next Michael addition. If we were to react the first compound, we may get a mixture of nucleophilic attack from either the left or the right carbon.